We augmented robotic devices commonly used to support rehabilitation across the continuum of care with an implantable spinal cord neuroprosthesis that promotes robust, organized, and sustained patterns of muscle activity in people with paralysis due to spinal cord injury. The neuroprosthesis involves the surgical implantation of a paddle lead for precise stimulation of the spinal cord and a neurostimulation platform operating wirelessly and in real time. The intended movements and device operations are detected based on external sensors to ensure time synchronization of the stimulation with the robotic actuation. Ergo allows early, graded, and safe mobilization of the lower limbs. We placed motion sensors on the frame and limb actuator of the robotic system and merged the signals from both sensors to ensure stability of stepping detection algorithms regardless of body orientation and speed. The stimulation promoted robust activities of the otherwise silent muscles. Sensors were placed on the crank of an exercise bike to elicit robust, sustained activation of lower limb muscles. Locomat enables stepping in people with complete paralysis. Synchronizing of spinal cord stimulation with the Locomat promoted sustained muscle activity that translated into a reduction of the body weight support and robotics assistance. Hand-pressed clickers or detection of forward arm movements with sensors enable walking over ground when supported in the rising. The same strategy enabled rehabilitation of visually guided walking movements in an augmented reality environment. The soft exoskeleton myosuit operated synergistically with spinal cord stimulation to improve balance and walking in people with complete paralysis. We developed an algorithm that scales the amplitude of stimulation patterns targeting leg extensor muscles based on the forces generated by the upper limbs during outdoor cycling activity. Spinal cord stimulation interfaced with assistive devices enabled walking over terrains covered with gravel, grass, or snow, and even progressing up and down staircases in people with complete paralysis. 2 participants with incomplete and complete paralysis walked for those who can't in order to raise funding to support research to fight paralysis.